Hi, welcome back to educator.com. This lesson is about the semantic web. For the past decade, Tim Berners-Lee and the World Wide Web Consortium have been promoting a new internet information model that they call the semantic web. The idea is that if we can mark up our content in a similar way that HTML marks it up, but in a fashion that allows us to program for better understanding on the part of the computer, then we can give meaning to our data that a computer can work with. That allows us to link data from different areas together and provide us with a much more rich interaction capabilities on the web. So in this lesson, we'll be discussing some of the technologies that make up the semantic web, including RDF and OWL, as well as some additional technologies that are popular, known as RDFA and microformats. With its use of customized element names for which a software application can then be intelligently programmed, XML forms a basis for this semantic web. Building on the foundation of a broader interpretation of Uniform Resource Indicators, or URIs, and the custom naming capabilities of XML, we get what's known as RDF. RDF stands for Resource Description Format, and it is focused on metadata, that is, information about the information contained in your web resource. Tim Berners-Lee is a big fan of metadata. It infuses just about everything he's done with the web. And RDF is kind of the crowning achievement of what he hopes will become the web's future. The idea of RDF is based on the concept of triples, that you have a subject, a predicate, and the object of that predicate. Let's take a look at how that works. Here's an example of how we might set up an RDF triple. Let's say we take a basic statement about a web resource. We'll say that Scott Anderson contributed material for educator.com's XML course offerings. That's how we might state it in basic English. Here we have the same statement, only formatted in a slightly different order to facilitate getting it into an RDF triple. We'll say educator.com's XML course, this is going to be our subject here, has a contributor, that's going to be our predicate, named Scott Anderson, and that's going to be our object. So here we have, again, our subject, our predicate, and our object. Now, what RDF allows us to do is express each of these ideas using namespaces and URIs. So, for example, our subject, educator.com's XML area, can be referred to its actual URI on the web, which would look something like this. Our predicate can be referred to by this URI here, DC, standing for Dublin Core, which is a metadata initiative, the idea being to come up with a sort of default set of information about just about any web resource you can imagine, whether it's a document or a picture or a website or print material migrated to the web, anything like that. And you can take a look at dublincore.org to see what their work looks like. Essentially what they've done is create a set of RDF-friendly elements that can be used to describe each of these. So contributor is one of these elements, and that can form our predicate. And then the object could be referred to by its own URI. This is not a real web resource or web area, but it might be a central database somewhere of online video educators, and then I would be part of that. So using URIs, we can create this RDF triple, and that allows us to express the concept that educator.com's XML course has a contributor named Scott Anderson, and that way we can put it in a way that we know the computer already understands. The computer already knows how to process a URI, and now we have this idea, this semantic idea, expressed in terms that the computer can read. So one of the ways that we can format RDF, there are actually several different ways, some of which are more conducive to certain purposes than others, but one of the ways we can take a look at it is with XML. And there is a file called rdfexample.rdf that's included here. And you can open this with Notepad or any text editor. It's not really web-friendly in terms of there really being anything to see on screen. RDF, again, is about not the data that you see, but information about the data that you see, the metadata. So what we've got here is we see that it's XML. And we set up our RDF element, which is our top-level element for RDF, along with the RDF namespace. And we set up a couple of other namespaces, DC for Dublin Core, and fake for our fake online educator database. And we'll pretend that there's a namespace somewhere for that. So what we have is an RDF description element, all of this material here. And then we use an RDF attribute called about, and there's our URI for our subject. And then contributor is our predicate from the Dublin core. And then this is our object, the value of that attribute, which is a reference to online educator Scott Anderson. And then if we want to, we could leave that empty if that's all we need, or if there's information at that resource that provides extra information about this contributor, such as if there's a database indexing system, what the ID number of that is, and then there's a full name, you can use that. So this is just an example of how we might use RDF to describe a certain web resource. In this case, educators.com's XML course area. Once we have our resource described, we can start making connections between different resources. And the technology that allows for that, which kind of builds on top of RDF, which builds on top of XML, which builds on top of URIs, is known as OWL. OWL stands for the Web Ontology Language. You might expect that its acronym would be WOL, but in reference to the fact that the Winnie the Pooh character by A.A. Milne named Owl spelled his name WOL, they decided to go the other way and call it OWL in reference to that. OWL is based on RDF schema. RDF schema is a schema language based on XML schema. And the idea of OWL is to create what are known as ontologies, which are very high-level bases of knowledge about resources. So, for example, we might say that if we have an RDF about Scott Anderson, we can use an OWL attribute, or an OWL element, I should say, called same as, which makes a reference to Scott Anderson, it referred in one place, being the same individual that's referred to in another place. And there is a file called OWL example. And it's really just the same RDF example, only we've got an OWL namespace here, referring to the namespace for OWL. And then we've included this OWL same as element so that the computer has that much more information to work with. The individual referred to in onlineeducators.fake is the same person listed in the list of educator.com instructors. So that the computer can make that connection so that if it's useful for any kind of data search, then the web can intelligently make that connection and put it to use for you. Another OWL example, this is not on a file, but you can take a look at the slide here, is that you can describe an individual as having a particular age. And then you can have specific data types. For instance, there's an RDF data type called integer. And we can use that to describe the person's age. Again, it's all meant to provide an even higher level of metadata, almost a metadata about our metadata, so that we can create very high-level processing of information that's stored on the web. Now, most of this information, this RDF and OWL, has been in place for almost a decade. It was finalized in 2004, all of a piece. They published about 14 different specifications describing RDF and OWL in detail hopefully in the idea that it would jumpstart this notion of the semantic web, that everybody would go to all their web pages and redo them in RDF or add all this RDF metadata and OWL metadata, and it kind of didn't happen that way. So as an additional effort to try to get the semantic web going, the Web Consortium later published a standard called RDFA. And the idea of RDFA is that you can add very brief attributes to your existing XHTML, presuming that you're writing your pages in that version of the HTML language. And that adds the ability to put RDF in an existing page without a whole lot of reauthoring. So what we might have in an old version of HTML is that we would use the meta element to give metadata to our pages, and we might use a meta element called author, and then we give it content. Now, the trouble with the old meta element name was that it didn't really have any specified means of describing what we meant by author. Okay, I can say that there's a piece of metadata called author, but there's not necessarily a central location of where that means. With the advent of RDF and the additional work by the Dublin Core, we can have some extra information there, and this is kind of the essence of RDFA, that if a browser supports RDFA, then it understands that this is the Dublin Core namespace, which you would declare in the head of your document. And then creator would have a specific standardized meaning across the whole web. So that if you're looking for pages created by Scott Anderson or web resources created by Scott Anderson, that RDF data could be lifted and kind of centralized and processed all together with RDF from other pages. Again, the Web Consortium's efforts toward metadata and creating a more intelligent web have been moderately successful. They've made some inroads in some areas and not others. But they are not the only effort going. One of the other efforts in this area that really doesn't have to do with XML, but it's worth mentioning, is something called microformats, where there are specific attribute values that you can put in your HTML that if your browser or some other program is developed in order to extract this microformat data, then it can have meaning in and of itself. So for example, v-event is a specific type of microformat data. Summary is understood by something that knows microformats, and then start dates and location all have specific meanings. But these are all in class attributes, which are an existing part of HTML. So you don't have to go through all the effort of creating RDF files or that sort of thing. You can simply use the syntax of HTML as it exists and then use these specific names that microformats understand, so that if you have a microformat processor, you can extract this information as well. So there are a number of different ways to add metadata to our web documents and resources. So in this lesson, we took a look at how the XML forms a basis of this newer idea called the semantic web, where the web is going to become more intelligent. If you've heard references to Web 3.0, that's what Tim Berners-Lee referred to it as a number of years ago after the idea of Web 2.0 caught on. The idea of the semantic web is that web content becomes machine comprehensible. It's not just a question of, here are some tags, and I'm going to spit their contents out into the browser screen so you can read them. It's, I'm understanding what I'm looking at based on the tag names and the RDF and metadata and everything, and I can make richer use of that for you. And there have been a number of different approaches to this. The Web Consortium's approach, microformat, several other initiatives around the way. They have all had their successes, but none have been 100% successful. So we're not quite in this semantic universe yet that everybody's envisioning. But these are some of the tools that their proponents are hoping are going to get us there. Thank you for visiting educator.com.